In this video, I'm going to share with you some questions from KMath 1. We'll focus on the order of operations. Let's get to work and have an example. So we want to do this question. Okay, I want you to set aside like the bed mass or pet mass or something like that. They are outdated and we are not going to use those like orders. In this question, you will see a counterexample that we are not going to follow that bed mass things. So according to bed mass, brackets come first, but it confuses the students, right? Because here we need to do 3 squared first. So it means before the brackets, we need to do 3 squared, which is the exponents. So 2 stays, minus stays, and 3 to the power of 2 means 3 times 3, which is 9 squared. Now we need to do inside the bracket. So inside the brackets would be 2 minus 9, which is negative 7 to the power of 2. And negative 7 to the power of 2 means negative 7 times negative 7. Since we have two negatives, it's going to be positive, and then 7 times 7 is 49. Next example. So 24 divided by 2 brackets negative positive 3 negative minus 7 to the power of 2. So the first thing that you need to do when we have, actually, first of all, you need to be aware that when we have nothing here, here should be times. And when we have division and times in one row, we start from left to right. So therefore, first thing that we do is 24 divided by 2. Obviously, half of 24 would be 12. So this is why we do 12, then times. Also, we know that when we have two signs next to each other, it's confusing and we need to reduce them to 1. So negative positive is going to be negative. Also here, negative negative is going to be positive. So therefore we'll have negative 3 plus 7. 12 stays. Negative 3 plus 7 is 4. And finally 12 times 4 is 48. Let's do another example. So what would be the value of negative 2 to the power of 3? This example is important because the number of negative numbers that we see here sometimes is confusing for students. So you need to treat this negative as negative 1. So it means this expression is no different from negative 1 times negative 2 to the power of 3. So you can treat negative as always as negative 1. So therefore, according to the definition of the exponents, it's going to be negative 1 times negative 2 times negative 2 times negative 2. As you see, there are 4 negatives, so it means the final, since the number of negatives is even, the final answer would be positive. And 1 doesn't change anything when it comes to multiplication, so 2 times 2 is 4 times 2 is 8. Next example is negative 2 to the power of 4 plus negative 2 to the power of 4. Often students are confused about the difference between these two expressions. Let's calculate negative 2 to the power of 4. So I'm going to go first with the bottom one. So in the bottom one, the base is negative 2 and the exponent is 4. So of course you need to multiply the base by itself as many as exponents. So it's going to be negative 2 times negative 2 times negative 2 times negative 2. There are 4 negatives, so the final answer would be positive, and 2 times 2 times 2 times 2 is 16, obviously. So in the next one, if you look at it here, the base is 2 alone because we don't have brackets. So negative has nothing to do with the exponent. So it means 4 applies to 2 only. And that negative, as I discussed before, you can treat it as negative 1. So negative 1 stays there, and you need to multiply 2 by itself 4 times. So there is 1 negative only, so the answer should be negative, and 2 times 2 times 2 times 2 is 16. Okay, so it means negative 2 to the power of 4 plus negative 2 to the power of 4. This one is negative 16, and this one is positive 16. So the answer would be 0. The following examples help students to understand what is the base. Okay, look at this example. What is the difference between these two expressions? In the first expression, the base is xy because of the brackets. Brackets show you that which letters are considered to be the base. But in the second example, you don't have brackets, so it means 3 does not apply to x. So if you want to expand it based on the definition of the exponents, so it's going to be xy times xy times xy. However, the second example would be x, y, y, y. These two, like if you compare these two answers, you would know exactly what is the meaning of exponents and how brackets apply. So let's have another example. X squared y cubed. This one even better can show you that the exponents, if there is no bracket, just that they apply to the letters immediately at the left side of those exponents. So it means this one can be written as xx or x times y, y, y. So we can have a numerical examples as well. So we can have like negative 2, negative 3 to the power of 2. Since brackets ends here, so it means 2 does not apply to negative 2. Negative 2 is just there. So we can write it as negative 2 times negative 3 times negative 3. The number of negatives is odd, therefore we will have negative, and 2 times 3 is 6 times 3 is 18. I hope these examples help you to understand better the meaning of the exponents and how does it apply when we have brackets or when we don't. Thank you for watching.